Well, hello, advanced algebra students, and welcome to Friday, our last day here of the week. And we're done with chapter 13, so we're going to be starting here with chapter 14. So you'll notice since we've finished up with chapter 13, I've posted as an assignment for you to turn in your notes from chapter 13 and also your notes from chapter 11. So that should be really easy. All you should have to do is just take a picture of your notes and post it. So that should be a nice boost to your grade without having to do any additional work. Just simply take a picture of the notes that you've taken for those chapters and post them. And that's something you can have done along with this assignment by Sunday night. Okay, so let's go ahead. Let's take a look at our trig identities. This will be the last chapter that we cover. And then we will just simply have a single test that'll cover chapters 11, 13, and 14. And we will definitely take a whole week of review to get ready for that. But we'll have that as being your last test for the class. And likely what we'll do is we will probably wrap up the class as the seniors wrap up, but we'll kind of see how that goes as we move through, since we have mostly seniors in the class. All right, so trig identities, 14.1. So basically what these are relationships between trig functions. And so the first type of relationship between trig function is the reciprocal identity. So the reciprocal identity is basically saying, okay, what's the relationship where something is the reciprocal of something else? So the sine function, we already really talked about this in the last section in 13 when we looked 13.8 when we looked at the graphs. So we said, okay, what's the reciprocal of the sine function? Well, it's the cosecant. And then we could also look at the cosine of theta and say, what's its reciprocal? Well, you should all remember from 13.8, it's the secant. And the tangent would be the cotangent. So these are basically what we already had from the previous section. So if I go a little fast, you just need to pause and write down the notes, and then you can finish. Now we can also take each one of these functions, and if we solve for them, we see that they also have a reciprocal that they're equal to. So the cosecant is equal to the reciprocal of sine. So if we simply multiply both sides by cosecant and then divide by sine, we get that the cosecant is equal to 1 over the sine. The secant we see is equal to 1 over the cosine, and no surprise, the cotangent of theta is equal to 1 over the tangent. So those are pretty straightforward, pretty simple. Now here's one that's new. And you could have already maybe deduced this or figured it out if you thought much about it. But this is one that's really important to know. And it's very easy to know, but it's very important. And that's the quotient identity. There are two quotient identities, and where that's basically going to say, what's the relationship between something to a quotient, which is basically a fraction, or something compared numerator to denominator. So the tangent of theta is equal to a quotient, a very important quotient to know. And I can show you this, I can illustrate for you if you want to think of it. If we think about what the tangent function, we think that it's the, well, I'll show you how this is true. It's the quotient I'll give you first. It's the sine of theta over the cosine of theta. And as far as how we can see this, we can see it if we go to take a look. I'll put down, quickly show you this is me working on the board as we're doing the notes here. If I was to quickly show you an example here of this, so you can ignore the stuff that's up. This is just, stuff that's on the board if we look at this. So if we look at the sine over the cosine, so we look at the sine theta over the cosine of theta, we know sine is opposite over hypotenuse. So we can put opposite over hypotenuse. And we know the cosine is adjacent over hypotenuse. Well, if I have a fraction divided by a fraction, that's equal to the top fraction, opposite over hypotenuse. Whoops. Write that a little bit better here. We have opposite over hypotenuse times the reciprocal of the bottom one, which is the hypotenuse over adjacent. Well, notice the hypotenuses cancel, and I just get opposite over adjacent, but that's equal to the tangent. So we see that the tangent of theta is equal to the sine over the cosine. So one way, if we know the sine and the cosine, we can simply find the tangent by dividing the sine by the cosine. Now, we also know from up here, the cotangent is the reciprocal of tangent. So if tangent is this, cotangent has to be the reciprocal of that, flip it, cosine over sine. So those are the two quotient identities. They're very important to know. They get used a lot. Now, the next type of identity to know comes from the idea of the Pythagorean relationship of right triangles. And so we can see how these Pythagorean identities come from this relationship that we see here within a right triangle. And I can go ahead and I could show you the same, just kind of like I did there with the cosine identities, where these things would come from. But, well, I suppose I could show it to you. I don't know how much. Yeah, let's go ahead and I'll quickly show you where it comes from so it can kind of make some sense. So if I take this out here, so if I look at a right triangle, let's say I have an angle theta, which makes this the opposite side, makes this the adjacent side, and makes this the hypotenuse, like that. Well, I know Pythagorean relation, as I look at this here, I know that I would have the opposite, and I'm going to call these, just so I don't have to write three letters all the time, I'm going to call this side A, this side B, and this side C. So I know that, well, actually, I guess I will have to call them opposite. Otherwise, it won't make sense to talk about the trig ratios. So I know that the opposite side squared plus the adjacent side squared has to equal the hypotenuse squared. But since this has an equals here, let's multiply the whole thing by 1 over the hypotenuse squared. So if I do that, this distributes into each thing, and I can do that because I'm doing it to both sides, so it's still going to stay equal. So I get the opposite over the hypotenuse squared plus the adjacent over the hypotenuse squared is equal to the hypotenuse over the hypotenuse squared. Oh, well, look at these things. Opposite over hypotenuse, what's that? That's the sine. So that's just going to be the sine squared of theta plus, and when we write this sine squared here, this is the equivalent, so in notation speaking, sine squared of theta is equal to the sine of theta, the entire sine of theta squared, like that. So that's what this notation means. So that's like saying the sine of theta squared. And I'm using this notation. This is the cosine squared, so we say cosine squared theta. And this hypotenuse over hypotenuse is 1. Anything divided by itself is 1, so we've got 1 squared or 1. This is our Pythagorean identity right there. So we are going to see, and by the way, the reason why we have this notation is that avoids the confusion of this. Well, what are you trying to say is squared? The theta or the whole sine of theta? So we avoid that. If we want the whole sine of theta squared, we put the squared here. If we want the theta to be squared, we'll put parentheses around that and indicate like that. That's actually just squaring the angle theta. So it avoids that confusion that could happen on something like that. All right, so our Pythagorean identity, we have the sine squared plus the cosine squared equals 1. And we have two other forms of this that are attained by, for instance, notice this has sine and cosine. It does not have tangent. How could I get tangent? Well, if I multiplied both sides by since I know tangent is sine over cosine, if I multiplied through by 1 over cosine squared, this would be sine squared over cosine squared, which would be tangent squared. This would be cosine squared over cosine squared, which is 1. And this would be 1 over cosine squared, which would be secant squared. So that's another form. Okay, now I've got sine, cosine, tangent, secant. I don't have cotangent or cosecant. Well, if I wanted cotangent, if I divided cosine squared by sine squared, I would get cotangent squared. So I'm going to divide through this basic 1 by sine squared. Sine squared divided by sine squared would be 1. Cosine squared divided by sine squared would be cotangent squared. And 1 divided by the sine squared would be cosecant squared. Now I have all 6 represented in a Pythagorean relationship. All right, now what you're going to be asked to do is pretty straightforward. This is number 9, and it says verify this relationship. So what I need to do is I need to show that if I multiply the cosine of theta times the tangent of theta, it equals sine of theta. So what I have to do is I have to re-express this as sine over cosine. So when I do that, I start with what I want to say here, re-express it as cosine of theta times, and instead of tangent of theta, I write sine theta over cosine theta. Notice now the cosine of thetas cancel, and I'm left with just sine of theta. That's all you have to do. Let's look at another one, 17. Asks us to simplify 1 minus the cosine squared of theta. It's saying, what is that equal to? Okay, well, if I go ahead and I look here, I guess I should say, so if I want to simplify this, I'm going to replace this 1 with sine squared plus cosine squared. So notice instead of 1, I put in sine squared plus cosine squared. Well, look here, I got cosine squared minus cosine squared. That's just 0, so all I have is the sine squared of theta. So just simply replace that 1 with the sine squared plus the cosine squared. And you know to do that because you've got squareds here. As soon as you see squareds and adding and subtracting, you immediately think Pythagorean identities. Finally, 25 asks us to simplify this. So notice I don't see any squarings or adding or subtracting, so I don't think Pythagorean identity. I think use reciprocal or, where I can, quotient. So here I could use reciprocal on this, and I could use quotient on this. The best way to do it is get everything into sines and cosines. Then it's easier to simplify. So I'm going to do reciprocal on this. So I'm going to call this the sine of theta times, and I know this is the reciprocal of cosine. So it's going to be 1 over cosine. And then this is going to be using the quotient identity, cosine over sine. So doing that, I notice that, sine in the numerator cancels with sine in the denominator. Cosine in the numerator cancels with cosine in the denominator. All I'm left with, everything cancels out. It equals 1. That simple. Okay, there's your homework. It's 8 through 26 even. There are 14.1. And hope that goes well. If you have questions, you can quickly send me a message through Classroom. Hope you have a good weekend, and we'll see you next week.